Evaluate lim s tend to 0 sin square x divided by 1 minus cos s. Now, in this problem, I'm going to solve this problem using two methods. First of all, I'll start with the L'Hopital rule. So the L'Hopital rule implies that you differentiate the numerator and the denominator separately. So I'm going to equate this. I'm going to differentiate it. D ds, the integral of, or the differential of sin square x. So what I'm going to do is this. I'm going to use a substitution for this. So I'm going to have a value for this. So I'm going to use a substitution for this. Let me say, let u equals sin x. So this automatically becomes d dx u squared. Now you know that when I differentiate this, u can be differentiated with respect to x. So by differentiating this with respect to s, I'm going to have a value of this. The y dx is going to be equal to the y du times du dx. What does that mean? So on differentiating this, I'm going to have 2u. So this is the y du. This gives me the y du. And when I differentiate this, I'm going to have du dx is going to be equal to the differential of this. That gives us cos s. So you see, when I substitute this into the whole of this, I'm going to have this. So this is going to be equal to d dx sin square s is going to be equal to the y du, that's 2u, times du dx, that's cos s. So when I multiply this together, I'm going to have, this is going to be equal to 2u. Okay, the value of u is sin x. So I'm going to have 2 sin x times cos s. So this value here, d ds sin square s, is going to give us, okay, let me write this way. So d ds sin square is equal to 2 sin s cos s, 2 sin s cos s. Now we're going to differentiate the denominator separately again. So by doing that, d ds 1 cos x minus 1 cos s is simply going to be equal to, when you differentiate, that will be 0 minus, and when you differentiate cosine, it becomes minus sine x, minus sine x. Now this is going to give us 0 minus minus 1, that's sine x. 0 minus minus sine s, that will give us sine s. Now, so I have to go back to the limit. This, we have already differentiated this and this, so I'll go back to the limit and place these values in for this. Okay, we've obtained the values of d dx sin square s as 2 sin s cos s, and d ds 1 minus cos s equals sine square. So the limit sin square s divided by 1 minus cos s is going to be equal to the limit s as s tends to 0. So sin square s is equal to 2 sin s cos s divided by the limit sine x. So you can see that from here, This will cancel out this, and we'll be left with the limit as s tends to 0, 2 cos s. Now you see what I've done with, I have continued to write the limit until I want to substitute. So when I want to substitute, I'm going to have 2 cos 0, that is 2, cos 0 is 1 times 1, which is equal to what? 2. So that is the L'Hopital rule method for solving this. You differentiate the denominator separately and differentiate the numerator separately. Now the next method I'm going to use trigonometry to try it out. So let me write down the limit again. So this is our limit once again. Now what I'm going to do, okay, let me work this one. What I'm going to do from trigonometry, we know that sin square s plus cos square s is equal to 1. We know that. So it therefore means that from here we can say that sin square s equals 1 minus cos squared s. And this can be written as a difference of 2 squared. So when I write this as difference, we're going to have 1 squared minus cos squared s. That's going to give us, by applying the difference of 2 squared, this is going to give us 1 minus cos x times 1 plus cos s. This is the difference of 2 squared. When you have two squares, a minus b, a square minus b square, the result is going to be a minus b, a plus b. So that is what I have applied to this. So now we can now go back to our integral and replace sin square s with this. So when I do that, I'm going to have the limit as s tends to 0. So sin square s is 1 minus cos s times 1 plus cos s divided by 1 minus cos s. So from here you can see that this will cancel out this. We'll now be left with, okay, let me push this one up this way. We'll be left with lim s tends to 0. We are left with 1 plus cos x. So we can now substitute. So that's going to give us 1 plus cos 0, which is equal to 1 plus cos 0 is what? 1, which is equal to what? 2, which is the same result for what we had as in the previous case.